Hello, my name is Colton, and along with my teammates Annie, Ben, and Chris, we are ABC Squared Filtration. As you know, our goal for this project was to design and build a filter that would remove dye from the wastewater of a local basket manufacturer before the water was discharged back into the environment. In addition to our main goal, we sought to create a filter that was cost-effective and required minimum maintenance. To do this, we set out to design a filter that had as many reusable parts as possible and a small number of parts that would need to be bought and maintained regularly, keeping the operating cost of the filter low. For our first design iteration, we chose to have small sections of charcoal separated by cotton and cheesecloth. This allowed us to use less charcoal for the filter, which would keep the cost lower. The first iteration also included a piece of filter paper as the very last medium for the water to pass through before it exited the filter. We had hoped this would increase the dye removal, and it did. However, the paper brought our filter to a grinding halt. There wasn't enough pressure to force the water through the paper, so our flow rate suffered significantly. In our final design, we made a few changes, the first of which was the removal of that filter paper. Ultimately, we decided that the difference it would have made in dye removal wasn't worth the losses we were seeing in the flow rate. Another big change we made from our first design iteration to our second design iteration was the addition of more charcoal in larger sections. Since it was the charcoal doing most of the heavy filtration, it only made sense to add more of it, and making the sections larger reduced the amount of cheesecloth and cotton balls necessary for the filter. So with those changes in mind, we came to our final filter design, which consisted of two large charcoal beds encased on either side by cheesecloth and a cotton ball, as you can see in the picture and diagram. When we tested our filter, we were able to remove about 43% of the dye. This wasn't quite as much as we had hoped to remove, but the addition of extra dye and the wear of the carbon late in the project was unavoidable. We were also able to filter 10 milliliters in somewhere under 2 minutes. Again, we were happy with this result as it was well within the allotted time frame. The total cost of our filter was less than $150, which we felt was reasonable for a commercial filtration system. On this slide, you will see a total cost breakdown of the filter. The total cost of the finished filter was $135. The most expensive portions of the filter were the housing, which cost $70, and the charcoal, which cost $35. Together, they accounted for 78% of our filter cost. While we were happy with our filter, there is always room for improvement. The first improvement we would have liked to make would have been the use of a larger filter housing. By increasing the diameter of the housing from just 1 inch to 2 inches, we would have been able to quadruple our filter size. This would allow for more charcoal and better filter performance. However, it would have had a major impact on cost. Another improvement that could be made would be the addition of a water reservoir. The ability to store more water for the filter increases its user friendliness and would also provide pressure to force the water through the filter faster, improving our flow rate. In addition to these, significant improvements could be made to the filter stand as well. A more robust stand would allow stability for a water reservoir, as well as the peace of mind that your filter isn't going anywhere.